Hello everyone, welcome to the NPTEL online certification course on fundamentals of food process engineering. So, this is our last class on non-thermal processing. We have by now discussed many non-thermal processing method which are helpful in preserving the fruits and vegetable without the thermal effect of conventional treatment. So, we have discussed the high pressure processing, pulse electric field and irradiation. Now, we will discuss the ozone and cold plasma technology followed by Hurdle technology. So, ozone in food processing. By now, ozone technique is very much familiar with most of the people, because we normally use now ozone to disinfect the water treatment plant or potable water, or for the surface cleaning of the vegetables, because when the surface are contaminated by some insecticides or pesticides or some microbes. So, we normally use the exposure to ozone. Okay. And the main advantage of ozone is that ozone does not give any adverse effect or some residue that to be removed from the surfaces. So, it is totally free, because when it get dissociated, it produce oxygen and that is not harmful. So, this is very effective. In June 1997, an expert panel of food scientists convened by the Electric Power Research Institute declared ozone to be generally recognized as safe, okay, GRAS. So, this is we know the food people, the people related to food industry or food processing know that before using any kind of chemical, we need to have this GRAS tag or this certification, so that we can safely use for the food. Ozone is useful in deodorizing air and water. So, this is already in practice, and is in almost every country use ozone as disinfectant while replacing its old sterilizing method like chlorination, because when we use this kind of chemical methods like chlorination, they have some ill effect because they leave some residue. Okay. So, either we have to remove that residue, or we have to bear the ill effect of those in food or in the surface of the food contact materials. So, this is one thing, and not only that, it reduce the use of water also, because when we use ozone, and that can be retreated or reutilized for the next batch, because that does not have any ill effect on the food or any residue that is harmful to the food. So, that is why these are now becoming popular. Ozone is a potent antimicrobial agent. It can effectively kill virus, bacteria, fungi and parasites, including those causing the food spoilage or human disease, that is the pathogenic. So, ozone can effectively kill, we can see that the broad spectrum of microbes are there. It can kill virus, bacteria, fungi and parasite. The concept of generating ozone. So, basically we develop ozone from oxygen by corona discharge method by applying the short UV, and then we can reframe it from the ozone to oxygen also. This is also possible, and there are more than one method. There are many methods by now for this generating ozone. The primary process used commercially today to make ozone is called the electrical discharge or corona discharge method. So, inside the machine, a high voltage electrical spark is fired across a gap, okay, like there is a gap across which the electrical spark is fired to turn the oxygen into ozone. So, while going through this high spark, the O2 converts to O3, right. So, these are the electrode, the upper one is high tension electrode and the lower one is low tension electrode. There is a dielectric material there and O2 is transferred across the gap. Okay. So, this is how we generate the ozone. So, this is one method, very common method. Now, ozone, because of this so much beneficial effect that it can act on microorganism, it has a very broad spectrum effect, because it can kill starting from the virus, bacteria, mold and pathogenic organism, then spoilage organism. It can have a varied effect on the microorganism. It can have the surface disinfestation effect, and also see there are some process where we want the sterilization effect, and for that we normally conventionally implement the sterilizer or pasteurizer, where we need high heat treatment, hot water or steam we utilize for that. Now, if we use ozone, so we reduce the energy intake to a higher amount, because we do not want them the like the plate heat exchangers or different kind of heat exchangers, that part we can omit, and the effect of that sterilization we can get only by applying the ozone. So, we are reducing some machinery, we are reducing some utilization of steam or energy or water, that we can reduce. So, by use of ozone we can significantly reduce the cost of production as well. Thereby, it is very beneficial in sauce production, dairy producers and milking system, it can be used, juice processing. So, everywhere for that heat transfer part, for that sterilization part, pasteurization part, we can replace by this ozone technique. Handling of fresh produce like fruits and spices, this can also be done by applying ozone treatment, so that no contamination will come. Water bottling plant, here also the sterilization we can perform by ozone. Breweries also, here the the destruction of the microorganism, this part can be done by the ozone treatment. So, different studies has been conducted to have or to see the effect of this ozone treatment on the food products. So, one such study we have reported here, it says that Hampson and Fury in 1997 has studied the germicidal effect of ozone on tomatoes. Okay. And what they found, there are certain sample, if you see in the x direction and y direction, we have raw tomatoes, then the N3 which is washed for 3 minutes in water with no ozone. Okay. So, this is N3, then we have 1 m, 3 m and 10 m. These are time of exposure to wash water containing the ozone, that means 1 minute, 3 minute and 10 minute we have exposed the tomatoes to wash water which is having ozone at a concentration of approximately 1 parts per million. Okay. So, ozone has excellent germicidal effect, that means the log cycle reduction, because log cycle here we have plotted in y axis and we can see that how much reduction it has occurred. Okay. Although we can see here one outlier, but that may be because of the experimental error. So, because other two are having some reducing effect. So, we can consider that it has some effect on the germs. So, bactericidal effect of ozone, we have seen the germicidal effect, now there is a bactericidal effect. Ozone is introduced to bacteria. So, what will form? The free radical or the atomic oxygen that will work on bacteria and eventually kill the bacteria, that attached to the bacteria, leaving the diatomic oxygen behind, and oxidative burst will happen that puncture the cell wall, okay, because atomic oxygen is highly reactive. So, it will break it, and finally, the diatomic oxygen will be there, bacteria will destroy, and this is not harmful for body. So, that is why treatment of ozone is very beneficial because it does not leave any residue behind. So, it is very effective. There are certain equipment, because ozone treatment by now is commercially available, and this is very popular nowadays. So, some systems are there, you can see, you can search in net also, these are market available systems. OSU, ozone based shell egg sanitizer, then there is ozone based produce sanitizer. So, whatever the fresh produce we can sanitize while passing through this channel, and then at the end we can collect them. There is a hopper for sending that. So, there is a ozone generating system. So, this kind of systems are available. So, ozone as a novel technology for CIP system. For closed process equipment, for example, there are some pipe, some vessels, some portions of the equipment, these are closed chambers and very not very easy to clean them. Okay. So, for closed process equipment in the food and beverage industry, ozone completely eliminate the need for traditional organic and chlorine based disinfectant. So, this eliminate the need for final disinfections, as oxygen being the only byproduct, because if we use this chlorine and other organic disinfectants, what happened that there are sometimes some fouling of the organic material deposited on the inner side of those closed equipments or closed parts of the food processing equipments. So, that has to be cleaned nicely, but it is very tough to disinfect those surfaces efficiently. So, if we use ozone, so that is very beneficial, because the ozone treated water that we use instead of that disinfectant plus water, that can be reutilized, because this does not give any kind of the contamination or any residue, it only gives the oxygen as a byproduct. So, that water can be reused. So, that is why for the CIP system this has become very efficient, the ozone treatment has becoming very efficient day by day. Total disinfection time is reduced due to the high disinfection potential of ozone, and high oxidation potential of ozone lower the application of temperature or the amount of chemicals used. So, high oxidation potential of ozone lower the application of temperature, because otherwise we need to use the hot water or warm water to completely have the disinfection. Disinfection volumes can be reused, as I said that the water that we are using for this can be reused. So, previously the typical CIP system was like that. First there is pre-rinse, okay, and each step that water is discarded, then there is cleaning, then there is rinse thoroughly, chemical disinfection. So, again this water should be thrown out or discarded, and again rinse. So, pre-rinse, rinse and rinse, these three we have purely involving the water, then cleaning and chemical disinfection, here also we use that. So, all this water have been wasted. Now, ozone tech CIP system. So, the ozone pre-rinse, cleaning, rinse and ozone disinfection. So, all this water can be reused for cleaning. Okay. So, this more efficient cleaning for this is used. So, cut to the total CIP cycle time and the resources as well. So, we have reached the conclusion part of ozone treatment. Widespread acceptability of ozone has made it very popular in food processing today. So, the properties of ozone has allowed its unrestricted and any food processing application. So, it can be used for any food processing application. Ozone has been demonstrated as the most effective biocide with significantly increased lethality, and we have checked that with many research oriented papers and works. Ozone requires very low contact time compared to chlorine and requires much lower concentration for effective killing compared to the conventional biocide. Okay. So, very low dose it is effective. Now, next is cold plasma. cold plasma is an upcoming technology that is nowadays used for basically surface sterilization. So, what is that? Plasma is a mixture of positive and negative charges as well as some neutral ions, neutral particle and photon. Plasma exists over a massive range in temperature and density. Okay. So, it actually have some mixed property of gas and the liquid, and so from the solid we if we provide energy to it, we are getting the liquid. If further we provide energy, we are getting gas, and again from the gas further we give energy. So, we get the plasma state. Okay. So, from the plasma state, as from the gas we ionize it and we get the plasma, and from the plasma to deionize it. So, we are getting the gas back, and then from the gas condensation liquid, and from the freezing we are getting the solid. So, this cycle is go on continuously. Okay. And this transition of energy from the lower to higher, then because of that the sublimation of ice to gas bypassing the liquid phase, and from the gas to deposition to solid. So, all such exist. Okay. So, this basically the states of the matter and how it can be transferred from one phase to the other. Okay. Now, cold plasma technology is a novel non-thermal food processing technology that uses energetic and reactive gases to inactivate contaminating microbes. So, energized gas. So, when gas to plasma it has become a energized gas. So, that can be used to inactivate contaminating microbes in food product. Okay. As for example, meat, poultry, etc., there we can use it. So, generation of plasma. So, basically the principle is first the radical ions generated, there is a nitrogen gas which is an inert gas. From then we are because by applying the high energy we are getting the ions and electrons and photons. So, plasma state having all of them, that is positive ion, then negative ion, then electrons, then photons, everything, and that ions into nitrogen and electron came from the neutron by plasma. Okay. They form the radical, photon, thermion and neutron. Now, when we apply very high voltage to the gas, this breakdown will form. So, here the formation of plasma we can see when the gas comes in contact with the plasma source antenna. There is a plasma source antenna, and when we give power to it, it generates cold plasma from the gas. Okay. Now, this plasma again through a superconducting magnets, this plasma move on to the radio frequency booster antenna, where this plasma is energized and then it release. So, we are getting then the accelerated plasma. Okay. So, it is first ionized. So, gas to plasma, then energized, okay, through this RF booster antenna, and then accelerate and then detach. So, now the plasma has been detached. So, these are now ready for application. So, next is classification of plasma based on the following aspects. So, plasma can be classified based on temperature variation, or based on the mode variation, or because of the pressure variation. So, for temperature variation, thermal plasma or hot plasma and cold or non-thermal plasma, these two separation can be made. Okay. Hot plasma and cold plasma. Then if we use the mode, that means how we are generating the plasma. So, based on that we can have the microwave plasma or gliding arc method or corona discharge method, dielectric barrier discharge method. So, these are all. Corona is the very basic one and common one, but these are the methods by which we can generate the plasma. And pressure, because pressure will also initiate that amount of formation of the plasma. So, because of that the low pressure, atmospheric pressure and high pressure, these are the pressure mediated change that cause in the plasma. So, the cold plasma that is mostly used for the food process application is one in which the thermal motion of the ions, this can be ignored or thermal motion is neglected. Consequently, there is no pressure force, okay, and the magnetic force can be ignored, only the electric force is considered to act on the particle. Okay. So, the electric force is actually functioning for decreasing the microbes or for death of the microbes. This plasma, the cold plasma, stayed cold because the temperature in the plasma reactor stays near the room temperature. That is why the thermal motion, those we can ignore. So, this is a particular setup where the cold plasma generation takes place. Now, areas of cold plasma technology used in food, where so far cold plasma technology has been used. So, cold plasma can be used for decontamination of products where microorganisms are externally located. That means, the surface, basically again the surface can be exposed and surface disinfection or decontamination can be achieved. For products such as cut vegetable and fresh meat, there is no mild surface decontamination technology available currently. So, cold plasma can be used for this purpose. So, for the cut vegetable, because normally we have seen when the cut vegetables are there, generally we are reluctant to take that. So, if we use this technique, so the surface microorganism or the surface contamination can be prevented. Then it can also be used to disinfect the surface before packaging or included as packaging process. So, during the packaging process, if we include this one, so no contamination will be there, nor the surface of the package and neither on the food products. So, this is how we can use this. So, a case study has been done on the chicken, where Campylobacter and Salmonella, these two bacteria contaminate over 70% of raw chicken meat. So, raw chicken meat, this was 70% contaminated by these two, and Drix et al. In 2012 applied a cold plasma to uncooked chicken for different time period. 3.5 log cycle reduction of bacteria from both the skinless chicken and the chicken skin itself, it has been found 3.5 log cycle reduction. So, these are effective. Another study has been seen where deactivation of Salmonella from the surface of almond has been seen, where 1.5 to 2.5 log cycle reduction has been observed. So, with time when this treatment has been given, so log of population reduction here has been plotted. So, we can get this much reduction. There is another case study on egg to have the surface sterilization. So, maximum reduction of 2.2 to 2.5 times log cycle and 4.5 log CFU per egg shell in Salmonella enteritidis level, showing a 90-minute of treatment at 35 and 65% RH respectively. So, when the high quality eggs are packed, okay, in the industry or the small entrepreneur shape, when people use this high quality of the eggs. So, the most common occurrence is Salmonella, okay, on the surface of the egg, and that can be prevented if the RH of the environment, as we can see, 35% and 65%. So, almost 90-minute treatment time is required to reduce the microorganism load from 2.2 to 2.5 times and 4.5 times. So, if this much reduction we want on the eggshell. So, this is the method that we can apply, and this is very efficient method. Salmonella typhimurium with an overall reduction of 3.5 log CFU per eggshell after 90-minute treatment is observed. Okay. Then sterilization of packaging material, this has also been tried, that the plasma has been exposed to the material, the packaging surface material. Close cold plasma sterilization allows fast and safe sterilization of packaging material such as plastic bottle, lids and films without adversely affecting the properties of the material or leaving any residue. So, that is why these methods are very helpful, and there are certain limitations of this technique, cold plasma technique. So, the limitations are, first is the important aspect of this technology are still immature. We have not gone too much deeper inside of this technique, and by now only the surface sterilization of few cases we use. So, the full potential of this technique is still to be explored, and what is the exact mechanism, how it destroy. So, that has to be defined properly. Optimization and scale up of commercial treatment level require a more complete understanding of this chemical process. So, that has not been done. This involves the high cost of production and installing the machines initially, variety and complexity of the necessary equipment. So, we have to work on this because there are variety of the machines required for different cases. So, to make it uniform we have to work. Now, antimicrobial modes of action for various cold plasma systems vary depending on the type of cold plasma generated. So, because the cold plasma also vary based on different parameter, for example, the temperature, the pressure. Okay. So, therefore, what kind of mode of action will be there, that also depends on the type by which we prepare the cold plasma. Now, the last is Hurdle technology. So, Hurdle technology, it means that there is not one method by which we can inactivate all the type of microorganism. Okay. So, we have seen by now that some methods are there that are effective only for the surface sterilization, some are effective only for the gram positive microorganism, some may be effective for the yeast and mold. Okay. So, there are different ways. So, and some methods are there, if we apply them maybe all microorganisms will be killed, but they will induce some undesirable changes in the sensory terms or the nutritional terms of the food material. So, Hurdle technology is combination of many technologies together that will have the destruction, complete destruction of the microbial contamination, as well as it will preserve the desired quality of the food. So, Hurdle technology is a method of ensuring that pathogens in food products can be eliminated or controlled. Hurdle technology usually works by combining more than one approach. Microorganism has to face several hurdles to survive in the product. So, finally, what will the hurdles will be taken in such a way, so that it will be even become tougher gradually, and so finally, they cannot survive. For example, we have seen here the pH is one trigger, the pH is one method by which we can give some obstacle to growth of the microorganism, because if we control the pH, then some microorganism are there that can grow in the normal pH range, some can in the basic pH and some in the acidic. So, if we control the pH, so some microorganism we can omit. Coming to the water activity, again we know that the different water activity is required for survival of the microorganism. If we lower the water activity, so many of the microorganism will not survive. and finally, we can impose the temperature effect. So, that the lethal effect of the temperature, or it can kill the any remaining microbes if it present. We can give this temperature for very short period of time, so that no loss in the nutrition can takes place. So, these are some common what we can say the hurdles that we normally apply. One is the high temperature, okay. One is the high temperature, then low temperature also, because if we reduce the the temperature to very low degree, frozen condition, okay. So, in that way also we can reduce the activity of the microbes. Acidity, that is one, then water activity, one hurdle. Redox potential, that we can control, we can add some preservative if required, and that is fully regarded as GRAS. Then aseptic packaging, that is while packaging no contamination will arise. So that we can give some cold plasma treatment or irradiation or pulse light treatment like that. So, we can perform the aseptic packaging. So, together we can design that which one in what combination if we can put. For example, in the second one we have given that the temperature effect, low temperature effect, then water activity, then pH, okay. Then redox potential, preservative, like that. Some microbes are there that can go up to the maximum extent of the combination. Some arrangement can be done where it can't reach can't cover one hurdle, okay. It can also be made in such a way, so that with one or two hurdle only it can stop. So, there are many methods, and we have to design based on the type of the product that we are dealing. So, principle of hurdle technology. Hurdle disturbs the homeostasis of the microorganism. Microorganism should not be able to jump over all the hurdle present in the product. Hurdles prevent microorganism from multiplying and causing them to remain inactive or die. Hurdles illustrate the complex interaction between acidity, water activity, temperature, etc., with which are significant in microbial stability. Finally, since in the non-thermal processing we gave many method like HPP, PEF, pulse light, irradiation, then ozone. So, I would like to give you a comparative table, so that you can understand and you can clearly remind that which methods are helpful in inactivating in what case, or what are the parameters related to them. So, this is the last part that I would like to cover in this particular chapter. Here we have one table, okay. So, we have comparison of different novel technologies or non-thermal technologies. One is HPP, then pulse electric field, pulse light. Nature of treatment, effective against the organism or the microorganism, then process parameter and the treatment range. So, high pressure processing, the nature of treatment actually by application of high pressure, and it is most effective on gram negative bacteria. So, effective against this, that means the gram positive is a bit resistant here. Process parameter, we can change the pressure, holding time, treatment time, that we can control. 100 to 900 or 1000 megapascal is the range of applying pressure here. We have pulse electric field, which is actually the high voltage electric field that we are putting across the food sample, and this basically works on the gram negative bacteria. This is effective against gram negative bacteria, and the gram positives are a bit resistant here. So, that means it does not mean that we can't use the use this method for inactivation of gram positive. Actually, in that case we need to increase the intensity to a higher extent, the voltage and the duration to a higher extent, or we can combine this with some other hurdle to control this. The process parameter that we can change here is the applied voltage, treatment time, number of pulses, distance between the electrodes. Okay. So, generally 20 to 80 kilovolt per semi we use normally. Third method is intense and short duration pulses, that is pulse light. We have seen that basically pulse light is active or effective for the surface sterilization. This effective on both, that is gram positive as well as gram negative bacteria. So, it works on all. And process parameter is we can change the pulse timing, pulse width, fluence rate, okay, pulse shape that can be changed, pulse duration ranges generally from 1 microsecond to 0.1 second, and we have mentioned already the broad spectrum light, that is around 200 nanometer to 1250 nanometer. This is the range in the electromagnetic spectrum. Next is we have irradiation and ozone. So, the irradiation, the nature of treatment is actually the ionizing radiation, that is the X-ray, gamma ray and electron beam, radiation from the electron beam that we are using. So, these are the resistance, if we see, it is high from gram negative to gram positive or mold, and then to gram then to spore, yeast and virus. So, that means the resistance of gram negative is very low than the gram positive than this. Okay. So, it has action on all of them and the process parameter, that is dose and time, that can vary. So, low dose 1 kilogram we have seen, this we apply generally for reducing the sprouting or ripening, degradation or disinfection of the pulses, or storing of the decontamination of the spices, etc. Medium dose 1 to 10 kilogram generally we use for inactivation from the bacteria, and high doses normally used for all the microorganism when we want to kill. Ozone, this is the nature of treatment is electrical discharge or corona discharge method. Ozone is a triatomic gas that we develop from the corona discharge method by using the oxygen when we pass it through the high voltage discharge, electrical discharge. And ozone has a broad spectrum biocide against the virus, bacteria, fungi, protozoa, etc. Both the spoilage and disease causing bacteria, disease causing organism on which the ozone can act. Here also the dose and time that we can change, 0.5 to 1 ppm, this is required for the surface treatment. And finally, we have cold plasma treatment. So, this is the mixture of the nature of treatment actually is done by mixture of positive negative charges or usage of reactive gases. This is effective against a wide range of pathogenic microorganism, basically used for a surface treatment, and process parameter is treatment time only in this case when the cold plasma generated, and treatment range. So, there is not any specific range has been identified. So, now by now, so cold plasma is one type of plasma. There are many kind of plasma can be generated based on the difference in the parameter of the mode or of the type by which it is generated, or application of temperature or not, and based on all this the effectiveness depends. So, that is why we can't mention any, we use only cold plasma for the treatment of the food inactivation, surface microbial inactivation of the food. So, this is all about the non-thermal processing of the food. Through this course, through this particular chapter of fundamental of food process engineering, we tried to expose you people to these techniques. All these techniques can be dealt with in a broader way, having lot many practical applications, equations and the problems, but since in our 12-week course actually the non-thermal was not part of all such unit operation that we discussed initially. This we have intentionally kept because these are all upcoming techniques that has very beneficial effect on the food, and many of you may in future want to work with them for as an entrepreneur or as a farmer or as a business person. So, these are the efficient technique, you can explore this. So, that is why we wanted to give a glimpse of all this technique in a brief way. So, thank you.